welcome everybody to the LSA. My name is Samantha Hardingham. I'm the academic director at the LSA, and really pleased to see everybody, some of you again, some new faces and new names appearing. So great to see you. I always like to recap a little bit and then look forward at the same time before we get on with our day's proceedings. Last week we were very pleased to be joined by James and Tom Tatum at Noisescape, who talked about the concept of any media as its user. Tom and James gave us a fantastic description of some of their projects in West London, thinking about new forms of inhabiting the city at relatively local scales, but really fantastic entrepreneurial ways of working as architects in London. That talk will be uploaded shortly, along with all of our other talks on Thursdays. So look out for that. Next week we have our very own Zafir Amin. Zafir is a recent graduate of the LSA, graduated last year, 2023, this year in fact, and is also the convener and coordinator of our Thursday Talk series. So really pleased, will be really pleased to hear from him next week, where he will talk about, in fact, his talk is entitled "You're Just a Part One." So I suspect one could read that in a number of different ways, and you will find out what he has to say. But if you really want to hear it live and direct and very fresh, please join next week and listen in to Zafir. But this week I am extremely pleased to welcome Rory Bergin from HTA Design. Thank you very much, Rory, for joining us.
My pleasure.
A little bit, a tiny bit of intro, which I hope sort of starts to frame some of what Rory's going to talk about. HK are one of the UK's highest, have worked on some of the UK's highest profile housing projects around sustainability. They are a sustainability consultancy as much as an architectural office. And one of those projects really includes the UK's largest zero carbon residential project, Hannam Hall. Spanning from low-rise suburban homes to high-rise, high-density living. You can see some of it behind Rory right now. Rory is partner and Sustainable Futures lead at HTA, and will explain the various tools and systems that are implemented across these projects. He'll also discuss the practices research projects for volumetric offsite construction and how it's utilised this technology across both residential and student accommodation projects. So all subject matter incredibly pertinent to lots of projects I saw personally yesterday from our second years, our final year thesis projects that students are starting to really get their teeth into now at this time of year. So I hope we've got several tuned in, and if they're not, I'm sure those that are will pass on the word and watch our recording. So without further ado, I'm going to hand over to Rory. And as always, if anyone's got any questions, please put them in the chat. We will make sure that there is about 15-20 minutes at the end of the talk where Rory can answer some of those questions. So please don't forget to put them in as you think of them. Over to you, Rory. Thanks for joining us.
Thank you, Samantha. And let me just set this to full screen. So so good afternoon, everyone, and thanks for joining. So I've been running the sustainability function within HTA for, I think, 16 years now. And before that, I was an architect, and I studied in Dublin, under sort of a normal architectural school, and then sort of progressively became more interested in performance, I think, building performance, and what goes into building performance, which led me to sort of lead the setting up of the team, and how the team works. And just to explain a little bit about how how we work in the context of the industry. So we employ a team of specialists within the team, most of whom are architects and most of whom have a sustainability master's of one kind or another. So from different universities around the UK and abroad. And so we offer services to our clients. So our clients come to us for architectural services to design buildings, and then, if you like, we bolt on as a fee earning proposition. We bolt on services like energy, sustainability, and so on, which I'll go into in more detail. And an area that we're working a lot on at the moment is what the rest of the practice does, what the architects do who are not specialists, and how they participate in this, and what they do at an early stage. Because what we've realized is that having a team like mine means that we can cope with really complicated technical matters, but we also need a lot of the rest of the team to be thinking about that at an early stage. So I'll talk about both of these sort of issues as we progress. So as a practice, we're around 250 people. So we're one of the biggest, if not the biggest, housing specialists in the UK. We've been going for about, I think it's 55 years now. And this is us in front of our recently acquired home in Hackney Wick, where we're very happy and recently moved. As a practice, we cover all scales of development, from large urban regeneration projects to renovation projects, and suburban extensions and parks and public realms. So we have a large landscape practice, which is now, I think, 45 people. So as a landscape practice, we're quite big. We occasionally win awards, and so we decided a long time ago that being architects was great, but we needed help. So hence the sustainability and building physics, interiors, planning, landscape, and so on. And we do like to build buildings. So we're not concept architects. We like to design buildings and build them. So we're quite technically minded, and we like to see things through from beginning to end, because we feel that if you design without sort of a full understanding of the technical requirements of what it is you're doing, you're kind of in danger of sort of going into territory where you can't go any further. You know, you might come up with a problem of materials or performance. That means you've got to stop and go backwards, which is often very difficult. We've a long sort of history of being involved and interested in innovation in housing. So in the center there is the Greenwich Millennium Village, which we were the original master planners and designers for, with Ralph Erskine, the late Ralph Erskine, and other projects which are to do with, say, prefabrication or sort of, interesting aspects of design and construction. So, we've participated in EU-funded projects, and we've participated in UK innovation-funded projects, and we continue to sort of keep that side of the practice going, because we think it's often really useful to be able to look at a particular topic in depth outside of the project, outside of projects themselves, because projects themselves are usually quite time-focused, and clients are usually in a hurry to get things done. So having the opportunity to research is really helpful. We set up this team, sustainability and building physics, as I said, about 16 years ago. And we have worked on some of the more innovative and difficult projects in housing in the UK in that period. And in order to do that, so we look quite holistically at projects in areas including daylight, including how we prefabricate and manufacture them. We look at sustainability standards like BREEAM and Home Quality Mark. We look at what the microclimate might be, how comfortable, how safe, how warm it is outside the public realm. Our designs often include domestic and non-domestic elements, so we need to look at sort of commercial spaces, thermal bridging, and U-value calculations. So looking at the nitty-gritty, how does a wall perform? How does a junction perform? All of these, as we drive down energy use and drive up energy performance, we need to look at things in more and more detail, including things like standards like Passive House and life cycle assessment. So life cycle assessment, looking at the environmental impact of materials, embodied carbon, embodied energy, and the pollution arising from the construction materials that we use. And then finally, an area that we're not doing as much as we'd like to do, but we are involved in post-occupancy evaluation in different ways, because we feel that if you don't look at post-occupancy performance of projects, how do you know that you've achieved the goals you set out to, in energy terms or in comfort terms, or just whether or not you've satisfied what the client wanted? Are children performing well in the school? We don't do schools, but if we did, are people happy, or are people content with the environment they've got? Do they feel safe? Really important thing in housing. Do people feel safe walking to and from the tube? Things like that. And while we use standardized tools, we also recognize that as sort of specialists in the field, that we sometimes need to develop our own tools. So this is a tool that we've developed, which we use to look at the sort of holistic sustainability of projects. So instead of just looking at carbon emissions, for example, what we often find is that in the context of projects, there's often somebody, perhaps the client or a planning officer or a consultant, who's got a very strong view on a topic. And you can spend a lot of time, if you're not careful, thinking about one topic. For projects to be successful, they sort of need to think hard about lots of topics. And these are, this is a list, I think, of 40 or 42 issues, which tend to occur particularly on our bigger projects. So areas to do with well-being, and amenities, the environment, landscape, microclimate, and social value. Social value being a topic that has become much more discussed and looked at. What is the legacy of the project? How is the project helping people? How is the project helping to involve different communities? How is it satisfying the needs of a variety of people? So expanding the scope of what we as architects do and think about. And so we use this tool to sort of illustrate to people that it's important to keep all of these sort of in play until you've made final decisions, and it's always important to think about, well, okay, so you can think about one area very strongly, but what impact does that have on other things? So for example, if you spend a lot of money, let's say in the project on say bringing down energy use, do you have enough money left to deliver affordable housing, for example? And of these two things, which of these is more important? So it's making sure that the full complexity of the problem is exposed. That doesn't mean there's always an easy answer to it, but it's important to recognize the problem. As I mentioned, we do have a bit of a specialism in terms of prefabrication, and we've built with clients and with factories over 7,000 units of housing. So some of those are hotel rooms, and some of them are student bedrooms, and some of them are, many of them are apartments, working with a number of different manufacturers, and we've delivered some very large projects using this methodology, which we think has a very bright future, but which is suffering at the moment, along with every other building contractor with interest rates and a slightly struggling economy. And so this is an illustration of a number of our buildings that have been built using that technology from 2014, 15 up to this year. So the one on the right, Enclave or College Road at Croydon. In fact, those two buildings on the right, 10 Degrees and Enclave, are actually beside each other in real life as well. So if you go to East Croydon railway station, they're a couple of 100 meters away from the railway station, and I encourage you to go and have a look. They're a couple of our most recently finished projects. Both of them are rental buildings. So 10 Degrees is a general apartments to rent, and College Road is a fairly unique building, insofar as it's a co-living scheme. So it's a early stage, early life stage accommodation is how we think about it. So people who are, say, moving to London for a short period of time, and they rent a small apartment in Enclave, and then it has a lot of shared amenities. So it has games rooms, it has fitness rooms, it has dining rooms, kitchens that are shared across all the residents. So kind of an interesting building model. It's a bit like a community, building a community from scratch with all the uses that you need within the building. So that instead of having to go to the gym somewhere else, the gym is on the third floor, and even instead of having to go somewhere else to eat, you can use one of the kitchens in the buildings. And then other of those buildings are student accommodation or normal apartment living. So quite a wide variety of building types, and all of them built in factories and brought to site on the back of trucks and then craned into place. And you'll see some images of those later on. And these are all the same buildings with a few more added in terms of appearance. So just to show you that prefabrication doesn't mean that everything has to look the same or needs to be sort of dull. So we spend a lot of time, particularly on the cladding, designing the cladding, designing the external walls to be interesting and to cope with a lot of the environmental issues that we have to deal with. So in terms of daylight sunlight, in terms of overheating, in terms of materials, in terms of technical performance, fire performance, and so on. And one of the specific areas that we spend quite a lot of the time working on these days and is about embodied carbon. So this is a diagram of 3 studies we've done on 3 of those buildings, looking at the embodied carbon of the construction and how that compares with a similar traditional building. So at the top line, you've got the business as usual scenario, and then the dark bars are the measurements from the buildings. And 2 of them, the 2 on the right, the 10 Degrees and the Valentines, are from post-construction analysis, and the one on the left is from pre-construction analysis. And it's kind of interesting to us that they're ending up very much in line with each other. But it shows, importantly, that we're achieving pretty high reductions from using prefabrication over typical traditional buildings. Now, I would say that while this shows the benefit of prefabrication, it is early days in the understanding of embodied carbon. And I would say that the existing benchmarks will change over time because we need to push the benchmark down, but also what's happened in the industry since the awful incident at Grenfell Tower, that the industry has become very, very risk averse indeed in terms of building performance and particularly fire performance. So we are moving away from using timber in construction, as there's a lot of nervousness about using combustible materials. A lot of it, I think, is misplaced nervousness, but nonetheless, the nervousness exists. And therefore, actually, the embodied carbon of lots of projects are going up instead of coming down, because we're unable to take advantage of the benefits of using timber in construction. So this is an area, I think, that particularly for the students among you, I think that is going to require a lot of thought and attention from you in your careers, because I think we've made a lot of strides in the last decade on bringing down the daily carbon usage, the operational energy usage in buildings, but we've a long way to go in terms of the embodied carbon usage of buildings by comparison, and particularly in the emissions relating to steel and concrete, the two primary materials. And of the two, sort of slightly weirdly, I think that we can make steel using renewable energy or lower carbon energy, but concrete, the production of carbon dioxide from concrete is part of the process of concrete and much harder to deal with. So that's just an issue. That's an issue for us to deal with as the profession moves forward. And at HTA, we've been collecting data on our projects for some time now. And this graph is an aggregation of data on multiple projects. What it shows you is that the bars are energy in buildings, so the daily energy use, and the green dots are the embodied carbon calculations. And we don't have the embodied carbon calculations for every project, but as you see, there's quite a few. And then the sort of brown line at the bottom, I don't know if you can see my pointer, but the brown line, which starts at 150 on the left, that's the trend line, what you call a trend line, an average performance, and that shows that operational energy use is getting lower at quite a good rate. The dotted line above, which starts at about 220 on the left, is also going down, and that's the average performance of embodied carbon, and that's going down, but it's going down at a much slower rate. So I suppose that's just an illustration that, for us as a practice, it's where we are, that we think we've made and are continuing to make quite good strides with operational energy, but we need to make greater strides with embodied energy. But as designers, we have more control over the operational, because we can specify U values, we can specify performance values. Whereas with the embodied energy, I think it's harder for architects to manage, because when it comes to construction, we have less control over contractors than we do over performance. But that's not to say that things are stuck and that we don't have any agency, but it's definitely in a more difficult box. So how do we deal with that moving forward as a profession? So to talk about some of these things in more detail about specific buildings, so the 10 Degrees project, which is one of those two prefabricated buildings, which is recently been completed near East Croydon. And you can see on the diagram, on the images here in the center, you can see one of the modules being craned into position. So this module here was made in a factory in Bedford and brought down on a truck. And it's a room, and it's quite a big one. So it's probably got a living room and a kitchen in it. And that living room will be painted, and the kitchen will have all the kitchen cabinets in, and it'll have the kitchen worktop. It'll have the cooker and the cooker hood. So the ceiling will be painted and the lighting will be in. So basically, inside, if you walked into the room as it's hanging there, which I don't recommend, but if you did, it would be pretty much finished, probably apart from the floor surface. Everything else will be finished. And that means that 90% of the work for that piece of the construction was done in a factory on the ground, in safe conditions, dry conditions, warm conditions, out of the wind and rain, and done very effectively. In our experience, construction workers in factories are twice as efficient as construction workers on sites, particularly on tall buildings. And if you think about tall buildings and the work that an operative has to do to get to where they're going, they've got to spend quite a lot of time on site getting to the place in the building they're going to actually fit a kitchen. And then if they take a break, they've got to go back to the site hut and have some lunch or whatever. In a factory, it all comes to them. You know, it's on the track and it moves around the factory from workstation to workstation, a bit like a car production line. So it's a very, very different approach to construction, much more effective, more difficult to get going in our experience, but once it's going, it works really beautifully. So you can see here, you know, a truck in the middle with the units being craned off. And at the bottom, you can see some of the metrics. So it's a quicker construction program. So for a project that's in a rush or a project where there's a big financial benefit to finishing earlier, then this is the way to go. Lower emissions, much less factory waste, fewer movements of equipment, and very little waste on site. So, you know, these buildings go up really quickly and have very little impact on their surroundings. And here is a typical layout of that project. And the sort of diagram at the bottom left shows the arrangement of modules compared to the plan. So the cores, the concrete cores are built pretty much using traditional methodology, and then the rooms are brought in from the factory and attached to the core, and then the cladding is attached afterwards. So you can see a sort of a sequence here where the cores are built first, then the modules are stacked up around them, and then the cladding is installed using mast climbers, those platforms that move up and down on the outside of the building. So a very mechanized, a very efficient set of processes from beginning to end, really. And some more construction photos, and then the completed. And the facade is very complex part to deal with. Having an interesting building, getting it to meet all the various environmental requirements, particularly things like overheating. So you see we've got shading over parts of the windows in the form of a sort of Juliet balcony, but interesting shapes in the facade too, so that the building appearance changes as light changes during the day. So it looks, the building color and appearance changes a lot because of its design. And then we also have amenities and, you know, internal amenities and external amenities in the building. And then next door to it is this co-living project called Enclave. And Nathaniel Furman, the artist, designed these terracotta or porcelain tiles, which are made in Stoke-on-Trent in a specialist factory, pretty much handmade in a factory. And you can just about see in that image that the colors change from top to bottom. So they go from white to deep blue. Sort of really, really interesting use of craftsmanship and materials. And the building as a whole is, you know, built in a similar way to 10 degrees, but with a more complicated facade and quite a different appearance. And again, it's you know, straddling, you know, the railway line beside East Croydon Station, and then getting a lot of benefit of daylight and sunlight from its surroundings and those interiors. And then another project in Ealing that we've done, again, this is all using manufacturing, and this is for an American client. These are buildings for rent, slightly lower scale, and more typical, more traditional apartments. And then a project that we're working on at the moment in Enfield, we're working to deliver a large regeneration project. And this is sort of an interesting part of the practices work, where we work with clients who have inherited existing estates, which are often failing because they were built badly in the first place in sort of 1950s and 60s. So we have the discussion about whether or not you should retain those buildings and renovate them, either because they're attractive buildings or well designed, or because of the embodied carbon that's built into them. So there's a discussion to be had about that. Generally, when we look at it, there are substantial benefits to not keeping them, particularly if they're badly built, because the costs of improving them are so high. And the embodied carbon calculation demonstrates that if you if you demolish them and replace them with highly performing buildings, and you triple the number of people who are living there and who get the benefit of living there, then other benefits outweigh the carbon costs. But it's an interesting calculation, a complicated calculation, and one that I think is changing as practice changes and as information changes. So we've done a lot of work on looking at how a project like this can work and how it can be built in phases. And we also use that tool I showed you at the beginning to compare different options. And one of the things about when you build new buildings is that you can meet all current standards. So at the bottom, on the bottom left, is where, in terms of performance, the existing buildings without change, where it scores. So, in some areas, it might have a lot of green space, for example, in an existing building. And perhaps the biodiversity is working well as it is. But there are huge areas of that wheel that can't be changed. When you refurbish it, there are some areas, particularly in terms of carbon emissions, heating and so on, that you can improve, but there's still vast areas that you can't change. Whereas with new build, you can have a much bigger impact. You're having some negative impacts as well, but you can also have many more beneficial impacts. And this is a sort of a discussion that is very live at the moment, because the discussion about what you should keep, what you should retrofit, why you should do one versus the other is a live question, and an interesting one that sort of bears constant discussion. And some of the analyses that we do as a team on projects like this is these images show sunlight falling on the ground. So what this is doing is it's looking at amenity spaces on the roofs of buildings as well as in the park. We're creating a new park, and we're looking at how many hours of sunlight do those get on the 21st of March, which is the sort of the solstice date or equinox date that we use to check such things. So a lot of testing of the design as the designs progress. An illustration of an early stage test to check what the impact is on surroundings. So you plot a line at 45 degrees from the buildings to the surroundings, and if it intersects with an existing building, you can tell it's going to have an impact. So you can see here, because we're building beside a railway line, that because of that, we're actually having very little impact on the surroundings. But this is the kind of early stage check that we do on projects to test whether or not we're having a beneficial or a negative impact. And then we do a lot of analysis on the performance of internal daylight. So you can see here some sample apartments from a building where we're doing internal daylight tests, and you can see here all the greens means we're doing very well. And then a couple of rooms at the top where we're doing less well, because on the one hand, one of them is a big room. So we've got a big, more generous space, but also we've got a balcony in front of it. So on the one hand, we're creating an amenity for the inhabitants because we're giving them a balcony, but balconies inevitably overshade or cast shade. So that means that you reduce the amount of daylight. On the other hand, and this is back to that wheel and having all of the issues. On the other hand, by shading it, we're reducing the risk of overheating. So I suppose I'm pointing out here the dangers of focusing on just one issue. And in my recent experience, planners and other authorities focus a lot on daylight, but don't focus nearly enough on overheating. And in the end, overheating is a bigger risk for residents, because if you overheat a lot and you can't get a good night's sleep, your mental health deteriorates rapidly, and actually your physical health is likely to deteriorate too. So in designing places for people to live, actually overheating is more of a risk factor, which is really a change, I think, particularly in the UK, because we're not really used to considering overheating as a risk factor in the UK. But because of rising temperatures, it is, and it's not going to get better, it's going to get worse. And then finally, a smaller project in Reading, so outside of London, where we're looking at building new homes around existing tower blocks and refurbishing the tower blocks. So a couple of 1960s tower blocks that are being retained and improved with residents staying in them. And then we're improving the performance of those buildings as much as we can by overcladding them and putting in good ventilation and making sure they're not going to overheat. And then looking at the new homes as well. So this is a kind of typical analysis that we're doing here, where we're looking at the sort of minimum on the left-hand side, which is the baseline, and then we're looking at multiple options. So running lots of different scenarios, so things like improving the U values, improving the performance of building systems and building services, adding greater amounts of photovoltaic panels or mechanical ventilation with heat recovery and so on. So this project, we aimed at zero carbon, which we achieved. So that's the option 5 on the right, the 100% zero carbon. And the other thing it shows is that the gray bar, which is going down, so those are the costs that the council, in this case, it's a council development, those are the costs the council would have to pay to itself, because many councils now have you could call it a tax. So if you don't meet zero carbon on the site, then they ask you to pay per ton of carbon you're not dealing with on site over a 30-year period. And that can add up quite a lot of money. So the gray bar is, as you improve the performance of the buildings, the amount of compensation, let's put it that way, the amount of compensation that you have to pay diminishes down to zero. So it becomes a balancing act between you can take money that you would otherwise have spent in compensation and you can spend it on the building instead. And then you can deliver better benefits to residents over time because their bills will be lower. And an issue for a lot of our clients, a lot of our housing association clients, is how can we reduce the bills for residents? Because energy costs have doubled or more than doubled in the last couple of years for various reasons. So the impact on affordable housing residents has been huge, and many of them, unable to pay for other things if they pay their energy bills. So it's really important for some of our clients that we're getting to low bills, quite apart from low energy. It's the low bills and the cost of running the buildings for people in affordable housing that becomes the driving factor. And then finally, on the same project, because we had existing towers to check and to improve, we also did some analysis on wind conditions. So looking at what is the impact of wind coming from coming down the face of towers? Is it safe to be near the towers? Are there things that we can do? Do we need to plant trees to mitigate the effect of wind? So that's a sort of a quick canter through a lot of the sort of analysis and thinking that we do as a practice, and that we try to apply to as many of our projects as possible. It's I would say that it's a constant learning experience. A lot of this has changed dramatically in the last 15 years since I've been involved, and will probably continue to change over the next 15 as you enter practice and become architects.
Fantastic. Thank you very much, Rory. Fascinating trip through a lot of parts of London. Is my can you hear me, or is it still?
Yeah.
You can. Okay, sorry, I was getting a little bit of feedback then. Really fantastic. I wondered if I could, I think you sort of pointed to it just now in your closing remarks, but given that your team is 16 years old, and I was really wondering, what do you think are the sort of most profound changes you've seen occurring since then? Obviously it must have taken a few years for you to think about setting up prior to that 16 years. So that's, we're probably looking at a couple of decades worth of development.
Yeah, I think that's true. And I mean, one of the reasons why we did it is that what we found was that and it's back to that wheel. What we found was that people who aren't involved in construction will say, and they will mean the best, they will mean well, okay, and they will say, you must achieve a U value of X, or you must achieve a thermal bridging performance of Y, or you must achieve an embodied carbon performance level of whatever. But if they're not involved in the detailed technical, work, they can quite easily stumble into something which is not achievable, or which is not technically deliverable, or which creates a risk somewhere else. So we decided we had to take control of it ourselves, because we understand the risks, we understand the technical requirements, we understand fire performance, insofar as we're allowed to. So I think in modern practice, I think you need to have a handle on all of these things within the team who are designing. Now that doesn't mean you have to have everybody in house, because that's quite difficult. But you need to have that knowledge to hand quite early on in the process. And I think we're finding, over that 15 years time, you need to have that knowledge in the project team earlier and earlier. So it's sort of stage one of design. You need to have that knowledge, or sufficient amounts of it, to be able to test options very quickly, because otherwise you end up going down a rabbit hole of a design which might look good and might convince everybody, and somebody might love it, and then it comes to the sort of crucial question. It has like too much of a negative impact on the neighborhood, or it has, or you can't justify the amount of embodied carbon that's gone into the building, or some other issue which the team didn't pick up earlier. So for me, it's that, thinking about these questions early in the design process.
I think it's so fascinating. The wheel is such a great device. I think, again, given where a lot of our second years are, particularly, that whole business of trying to negotiate and keep bubbling all of the different aspects of a project, knowing what comes to the fore when, and that sort of negotiation between different parts of projects, I think is incredibly complex. One, to visualize, two, to identify, and three, to then start to kind of decide to prioritize. So incredibly useful device, I would imagine. Talking to a lot of different, all the different stakeholders and members of the team, as you say. Thanks so much. And now look, I do have a few questions here, so I'm going to try to get through as many of them as I can in our sort of final. Well, we've got about 12 minutes to go, which is plenty, I think. So we have a question. Did Rory complete another master's after working as an architect to take on the role he is in now, that you are in now?
Good question. So I took on a master's earlier where I did what was called the Intelligent Buildings Masters at Reading. And that kind of looked at all sort of aspects of construction, so sort of smart construction, impact on people. So it wasn't called sustainable design, but in many respects it was. And almost everybody, I think everybody in my team and everybody who has ever been in my team has had some postgraduate training. So I think Oxford Brookes had a master's, or still have a master's. UCL have a master's. Nottingham have a master's. Cardiff has a master's. Sheffield have a master's. All on different aspects. Of course, Cambridge have a master's. So all on different aspects of sustainable design, environmental performance, and so on.
And these are master's courses that post part 2, as it were. So yes. You're qualified. You're all going through the architectural training and then doing it's additional.
But then say Nottingham, I know in Nottingham's diploma they run a sort of joint sustainability design degree, not the diploma actually. So in the degree you learn quite a lot about environmental performance and at least one of our team members has been through that process. So much earlier in their training, and not waiting until the masters, and using the tools to inform design from the beginning. I would say too that a lot of the tools that you need to use are available for students. So there are student versions of tools that are widely available, and there are sort of tools like Rhino and Grasshopper, where there's a whole ecosystem of tools that people can learn. And there's an interesting tool coming out of Autodesk called Forma, which is a sort of an early stage design analysis performance tool. And there are probably others. There are probably others. So people don't necessarily need to wait and be taught about these things, that you can find quite useful analytics tools available already.
Yeah, great. Thank you. Okay, this is a slightly different one. What is your stance on the increase in mass timber construction technology that's arguably environmentally friendly, can be treated to be fire retardant wood, and acts as a carbon sink? You touched on timber earlier.
Yeah. So I mean, all of that is true, and all of that is good. I think for specific buildings, absolutely go for it. I think where problems occur, and we operate in the housing sector, and we always like to think about how can things scale up, and how far can you take it. So I suppose we're wary of doing things which, when you scale up, then become a problem. So the only question I have about mass timber is, if we scale it up, what happens then? And are we better off leaving the trees to continue to absorb carbon? So I think so long as you're not damaging the capability of the forestry to absorb and store carbon, then you should be using timber. Absolutely. And we do a lot of low-rise housing, which is timber framed. So it's not mass timber. It's using less timber. It's timber framed rather than mass timber. Yeah. I suppose I do slightly question the use of mass timber for taller buildings, because I think in the scheme of things, we probably don't need that many tall buildings, and it's the lower rise buildings, I think, that's more kind of interesting and appropriate. So yeah. Not a straightforward topic, and not a straightforward answer.
No,
I'm all for the technology.
But very good point, which is, to do with building type and, appropriateness and volume.
Schools, fantastic, perfect.
Really interesting. Yeah, we had an interesting talk a couple of weeks ago from a practice in Rotterdam, Studio Nauta, who talked about a project that's going ahead now, building low-rise housing, but then planting forests for long-term maintenance of that complex of buildings. So building in that circular economy essentially into the project, and getting the buy-in by regions to do that. So that obviously extends the scope of a project hugely.
I mean, it's really sort of a weird one, is that until the Ukraine invasion, quite a lot of UK timber used to come from Russia, and now it comes from Canada instead. So
long way.
So it's a very, very strange thing, to change, but
it's a factor.
Strange. It's a factor.
Yeah. Okie doke. Another question: do HTA projects use any other external sustainability resources or consultants, or is it all strictly in-house?
We can't cope. Yeah, we can't cope with we couldn't possibly cope with all the requirements on all our projects. So my team, if you like, deals with the analysis requirements of maybe 2 or 3 projects at a time, because what tends to happen is, and this is what we want to happen, is that on a single project we will do the daylight overheating, energy, circular economy, whole life carbon. And that means we can give a joined up response, but we can't possibly do that for all of our projects at the same time. The resource requirements are too high, or in London in particular, the resource requirements have become too high. And we could have a whole separate conversation about whether or not some of those regulatory requirements, particularly in London, are heading in the right direction. We now have, if you printed all the guidance to do with sustainability in London, I think you'd have a pile of about 300 millimeters thick. And it's constantly changing. So I would argue that some of that goes too far, particularly at early stages of projects. But maybe that's because of the way the construction industry operates in housing, which is usually design and build. So a lot of the questions that they're asking, we find it very difficult to answer, because until you have a contractor on board, lots of the questions are in the air. But maybe that's the wrong approach. Maybe we need to stop thinking about contractors and making more decisions earlier, which is then a problem for our clients, because our clients then need to spend more time and energy making decisions at an earlier stage.
Yeah, it's yes, that balance. I mean, how do you sort of go about keeping on top of those 300 millimeters of? Is that part of sort of routinely your process and design process and weekly process of bringing in, reviewing that literature and directive, or is it more applied directly to the pieces of work that you're doing, do you think?
I think we generally, when we're doing a piece of work, we have to check that the information has not changed. But so, for example, we on one of our projects, we did an environmental impact assessment, and in the period when we had the design, did the assessment, and then in the period when we were writing up the assessment, a piece of legislation changed. So what do you do then? Do you go back to the start, or do you say, no, we'll think about that later on? So constant change but I suppose that's a fact of life, right? That's a fact of life, particularly environmental matters, as people are getting to grips with new thinking.
Yeah, really interesting. I think we have time for probably one more question, which we have one here, which is, inevitably, as the design and stages progress and systems and elements are scrapped during value engineering, how much of a voice does your team have during this in terms of pushing for some aspects to be kept in order to retain a low embodied carbon and uber sustainable stature?
Yeah, I think that's an interesting. I think the answer is more and more as time goes by. I think the Building Safety Act and Grenfell disaster is having a seismic effect on the industry and how it thinks. So I think there's going to be behavior about value engineering, which is pre-Building Safety Act, and then behavior post-Building Safety Act. And our expectation is that post-Building Safety Act implementation, full implementation, value engineering will have much less scope, because once you've designed the building and you've got approval for it, it's going to be really difficult to change. So some of those issues I talked about earlier on in terms of legislation and regulation and so on, may well go away, because we will simply have to fix more things at an earlier stage of the building, and what value engineering can change will be much less. So the onus will be on architects to be better informed and to design buildings which don't need value engineering. If value engineering is usually a sort of an illustration of some failure somewhere in the process, where something has been over-designed or over-specified. So the onus, I think, is on us as a profession to be on top of costs, on top of embodied carbon, so that constant changes and constant revisions aren't necessary post-design, post-detailed design. It's a good challenge to have.
It is a fantastic challenge to have, and one that I suspect modular design goes quite a long way to help. I suspect for certain kinds, certainly tall buildings.
That's true. That's true, because you have with manufacturing, you have to fix the design earlier, and then you can't change it once production begins. That's it. It's fixed.
Yeah.
Very
fantastic. Thank you. Well, we've come really to the end. We have about 2 minutes till 2 o'clock, which pretty well gives everyone time to finish their lunch and get back to work. So I think we'll probably draw to a close now. But thank you so much, Rory, for a really interesting hour. Thank you. Please do come and visit us at the LSA. I hope you'll come and review some of our students' work, and lots of this, all of this knowledge would be incredibly helpful to them, I know, certainly in a few months' time when they really start to get to the nitty-gritty of engineering their own projects.
Yeah. Well, I'd be happy to do so.
We'd be delighted. Thank you so much, and thank you to everybody for coming today. Great to see you all, and look forward to seeing you next week with Zafir. When Zafir will be here, I will not be here. So see you all I will see you all in 2 weeks, and look forward to it then. Thanks again, Rory.
Okay. Thank you. Bye.
Bye-bye.